Hello students, in this session of database management system, we'll be discussing about introduction to DBMS, need for DBMS, types of databases, components and application of DBMS along with the advantages and disadvantages of DBMS. Let's proceed with the introduction to DBMS. The data is a term that denotes the raw fact and figures. Database is basically a term that denotes a collection of logically interrelated data. Database management is creation and maintenance of collection of organized data. While a database management system is a software package designed to define, create, maintain a database and provide the controlled access to the data. So, we can say the data must be formatted for storage, processing, and the presentation. And a database is basically the organized collection of structured information or the data typically stored electronically in a computer system. A database is usually controlled by a database management system. For example, the college database organizes the data about the admin, staff, students, faculty, etc. Using the database, you can easily retrieve, insert, and delete the information. The database management refers to the action a business takes to manipulate and control data to meet the necessary conditions throughout the entire data lifecycle. The database management system is basically a collection of programs that enable the users to store, modify, and extract the information from the database as per the requirements. It is an intermediate layer between the programs and the data. Commercially available databases in the market are DBase, FoxPro, Oracle, SQL Server, DB2, and many more. Now, coming to the part need for DBMS. The basic causes or needs for DBMS are that highly efficient method of handling large amount of data, systematic storage of data, easy to retrieve, filter, sort, and update. Also, it can be used for creation of database, retrieval of information from the database, updating and managing the database. It provides us many functionality and are more advantageous than the traditional file system in many ways. First of all, processing queries and object management. In the traditional file system, we cannot store the data in the form of object. In the practical world application, the data is stored in the objects and not file. So, in a file system, some application software maps the data stored in files to object so that they can be used further. We can directly store data in the form of objects in database management system. The application level code needs to be written to handle, store, and scan through the data in a file system, whereas a DBMS gives us the ability to query the database. Next, controlling redundancy and inconsistency. Redundancy refers to the repeated instances of same data. A database system provides redundancy control, whereas in a file system, same data may be stored multiple times. For example, if a student is studying two different educational programs in same college, say engineering and history, then his information such as phone number and address may be stored multiple times, once in the engineering department and other in the history department. Therefore, it takes times to therefore it increases the time to access and store the data. This may also lead to inconsistent data states in both the places. A DBMS uses data normalization concept to avoid redundancy and duplicates. Next, the efficient memory management and indexing is also a basic cause of need for DBMS. DBMS makes complex memory management easy to handle. In file system, files are indexed in place of objects, so query operations require entire file scan, whereas in DBMS, object indexing takes place efficiently through the database schema based on any attribute of data or a data property. This helps in fast retrieval of data based on indexed attribute. Next point, the concurrency control and transaction management. Several applications allow user to simultaneously access the data. This may lead to inconsistency in data in case files are used. Consider two withdrawal transactions, say X and Y, in which an amount of 100 and 200 is withdrawn from an account, say A, initially containing 1000. Now, since these transactions are taking place simultaneously, different transactions may update the account differently. X reads 1000, debits 100, and updates the account A to 900, whereas Y reads 1000, debits 200, updates A to 800. In both cases, account A has the wrong information. This results in data inconsistency. A DBMS provides mechanism to deal with this kind of data inconsistency while allowing users to access the data concurrently. Next, the access control and ease in accessing the data. A DBMS can grant access to various users and determine which part and how much of it could be accessed by thus removing the redundancy. Otherwise, in the file system, separate files have to be created for each user containing the amount of data that they can access. Moreover, if a user has to extract specific data, then he needs a code or application to process that task in case of file system. For example, suppose a manager needs a list of all employees having the salary greater than, say, X, then we need to write a business logic for the same in case data is stored in files. In case of DBMS, it provides easy access of data through the queries. Example, the select queries. And whole logic need not to be rewritten. Users can specify exactly what they want to extract out of the data. Another part, integrity constraint. The data stored in databases must satisfy integrity constraint. For example, consider a database schema consisting of various educational programs offered by a university such as BTech, MTech, BSc, MSc, BCA, MCA, etc. Then we have a schema of students enrolled in these programs. A DBMS ensures that it is only out of one of the programs offered schema the student is enrolled in, not anything out of the blue. Hence, the database integrity is preserved. Apart from these features, a DBMS also provides multiple user interface, data scalability, expandability, and flexibility, along with the data security. And the data security is assigned by assigning the security permissions and restricted access to the data. Coming to the next part, types of databases. The types of databases could be stated as centralized, distributed, relational, cloud database, and many such more. The centralized database is the one that stores the data at a centralized database system. It comforts the user to access the stored data from different locations through several applications. These applications contain the authentication process to let the user access the data securely. An example of centralized database can be the central library that carries a central database of each college and university. There are certain advantages of centralized database. It has decreased the risk of data management, that is, manipulation of data will not affect the core data. Data consistency is maintained as it manages the data in central repository. It provides better data quality which enable the organization to establish the data standards. It is less costly because of few vendors are required to handle the data sets. But also there are certain disadvantages associated with the centralized database. The size of centralized database is large, and also it is not easy to update such an extensive database system. If any server failure occur, the entire data will be lost, which could be a huge loss. Another type of database system is distributed database. Unlike a centralized database, in distributed systems, the data is distributed among different database systems of an organization. These database systems are connected by communication links. Such links helps the end user to access the data easily. For example, distributed databases are Apache Cassandra, HBase, Ignite, etc. Another type of database system is relational database. This database is based on relational data model which stores the information in the form of rows and column, and together that is a form that similar to a table. A relational database uses SQL, that is structured query language, for storing, manipulating as well as maintaining the data. Dr. E.F. Ford invented database in 1970. Each table in database carries the key that makes data unique from other. The examples of relational databases are MySQL, Microsoft SQL Server, Oracle, and such similar. Another type of databases are cloud-based systems. A cloud database is basically a type of database where the data is stored in a virtual environment and executes over the cloud computing platform. It provides user with various cloud computing services like software as a service, platform as a service, and infrastructure as a service, etc. for accessing the database. There are numerous cloud platforms, but the best options are Amazon Web Services, Google Cloud, SQL, Microsoft Azure. Then we have object-oriented databases. These are the type of databases that use an object-based data model approach for storing the data in the database. The data is represented and stored as objects which are similar to the objects used in the object-oriented programming languages. Another we have hierarchical databases. It is the type of database that stores the data in the form of parent-child relationship node. Here it organizes the data in a tree-like structure. The data gets stored in the form of records that are connected via links, and each child record in the tree will contain only one parent. On the other hand, each parent record can have multiple child records. Next, we have another type, that is network databases. It is the database that typically follows network data model. Here the representation of data is in the form of nodes connected via links between them. Unlike the hierarchical database, it allows each record to have multiple children and parent nodes to form generalized graph structure. Another one, we have the enterprise database. The large organizations or enterprises use this database for managing a massive amount of data. It helps the organizations to use or increase and improve their efficiency. Such a database allows simultaneous access to the user. And the major advantages of enterprise databases are the multi-process they support, and that it also allows executing parallel queries on the system.